Section D, the least common multiple.
Before we get into the least common multiple, or LCM, let's take a minute and talk about what a plain old multiple is. A plain old multiple is what you get when you multiply one number by another number.
All right, let's take the number 3. What are its multiples? Well, 1 times 3 equals 3. 2 times 3 equals 6. 3 times 3 equals 9. 4 times 3 equals 12. 5 times 3 equals 15. 6 times 3 equals 18. 7 times 3 equals 21. And 8 times 3 equals 24. So the first 8 multiples of 3 are 3, 6, 9, 12, 15, 18, 21, and 24.
And now, it's the artist formerly known as the least common multiple. Give it up for the LCM. To find him, just look in a few lists of multiples. He's the number with the smallest numerical value that appears in all your lists. Take a look.
These are some multiples of the numbers 6, 10, and 15. What we want to do is figure out the least common multiple of all three. So, the LCM is the multiple that 6, 10, and 15 all have in common and has the smallest numerical value. You might notice that 60 is a multiple in all three lists, but so is 30. Because we're smart, we know that 30 is smaller than 60, and 30 is the smallest multiple they all have in common, which means 30 is the LCM of 6, 10, and 15.
When you're listing multiples, the fastest way to find the least common multiple is to look at the multiples of the largest of the numbers. So, for our previous example, to find the LCM of 6, 10, and 15, 15 is the largest number, so you would look to the multiples of 15. First, try 1 times 15, or 15. 15 is not a multiple of 6 and 10, so next try 2 times 15, or 30. 30 is a multiple of both 6 and 10, as well as 15, so our number is 30.
Listing multiples, like we just did, is one way of finding the least common multiple, but there is another way to do it. Any guesses?
Look in the back of the book.
Nice. But no. We're going to use the prime factorization method. Let's use the same numbers, 6, 10, and 15. Now remember way back about 2 minutes ago when we found the GCF? Well, our first step here is the same. We're going to factor with tree diagrams and then give our prime numbers exponents.
So, if we take 6, we get the prime factors 2 times 3. 10 breaks down to 5 times 2, and 15 gets mapped out so that its prime factorization is 5 times 3.
Now we've got all our prime factors and we need to express them with exponents. This part is a little different from the greatest common factor. To represent the LCM with prime numbers and exponents, we need to take every prime number that appears as a prime factor and write it once with the biggest exponent that appears. Take a look.
Since the prime numbers we see are 2, 3, and 5, we're going to use each of these one time and give them an exponent. For the LCM, we use the biggest exponent for each prime number that is represented. This is different from the GCF, where we use the smallest. Notice in this example, the most each prime number appears in a single factorization is 1 time. So the biggest exponent we can use for each is 1. That means the LCM of 6, 10, and 15 is 2 to the first power times 3 to the first power times 5 to the first power, or 2 times 3 times 5. See how when we multiply 2 times 3 times 5, it equals 30, which is what we got before when we compared multiples with whole numbers.
Excuse me.
Dude, get the mustard, dude!
When you multiply your prime numbers with exponents, they equal my whole number. I checked it out.
What now, dude? There's nothing left now but math. Hey, let's get the LCM of 10 and 25.
Doing the prime factorization of 10 and 25, 10 breaks down to 2 times 5, and 25 breaks down into 5 times 5, or 5 squared. At this point, we're already down to our prime numbers, so we want to represent all the prime numbers that appear. In this case, we've got 2 and 5. So what is the most number of times 2 appears in a single factoring? Well, it's just 1 time. That means our exponent for 2 is 1. What about 5? The most 5 appears in a single factoring is 2 times, so 2 is our exponent for 5. That means the LCM of 10 and 25 is 2 times 5 squared. If we multiply the LCM out, we get 2 times 5, which equals 50. And remember, we can check the LCM by listing the multiples out this way. And here we see that 50 checks out as the LCM.
Ta-da!